Hi everyone, welcome to the part 3 of the Linux Essential full course provided by Network Elite. I hope you keep watching this course till the end to be ready for your exam. So please subscribe this channel and write down your favorite next IP topic below. Sometimes understanding the principles and philosophy that underlie a technology can be useful, and knowing this might even guide your choice. This is true of some Linux users. The open source model of Linux has implications that can affect how Linux works. Furthermore, some in the Linux world can become quite passionate about these principles. Whether or not you agree with these individuals, understanding their point of view can help you appreciate the Linux culture, which you'll find in the workplace, online, at conferences, and so on. This tutorial covers these issues, beginning with information on Linux's origins and its development over time up to the present. We then describe open source principles and how they can affect the way an open source OS works in the real world. Finally, we describe some of the roles in which Linux can work as an embedded OS, as a desktop or laptop OS, and as a server. In this part, we are going to talk about Linux through the ages, using open source software, and understanding OS roles. Linux through the ages. Although Linux's birth date of 1991 is recent by most historical standards, in the computer world 25 years in an eternity. Nonetheless, the software and culture in early 1990s and even before then has conveyed quite a legacy to the software world. After all, what we use today is built atop the foundation that was created in the past. Just looking at how Linux originated will help you understand Linux as it exists today. Computers could belong to any of a handful of categories ranging from desktop personal computers or PCs to supercomputers. x86-based computers, which are the direct ancestor of today's PCs. However, other types of PCs were available, including Mac computers. Such computers generally used different CPUs and ran their own custom OSs. DOS was extremely limited by today's standards. It was a single-tasking OS. It could run only one program at a time that didn't even take full advantage of the memory or CPUs available at the time. The versions of Microsoft Windows available in 1991 ran on top of DOS. Although this initial version of Windows helped to work around some of DOS limitations, they didn't fundamentally fix any of them. Unix supported multiple accounts and provided true preemptive multitasking, in which the kernel could schedule CPU time for programs, even if the programs didn't voluntarily give up control. The OSs used on the PCs of 1991 didn't scale well to more powerful hardware, and today's PCs are now powerful enough to run the more sophisticated OSs of 1991. For this reason, DOS and its small computer contemporaries have been largely abandoned in favor of Unix and other alternatives. Torvalds began the program that would become the Linux kernel as a low-level terminal emulator. He began adding features that turned his terminal program into something that could be better described as an OS kernel. Eventually, he began writing with the goal of creating a Unix-compatible kernel, that is, a kernel that could run the wide range of Unix software that was available at the time. Early Linux developers were particularly keen on the GNU's .Unix GNU project software, so Linux quickly accumulated a collection of GNU utilities. Linux is an example of monolithic kernel, which is a kernel that does everything a kernel is supposed to do in one big process. In 1991, a competing kernel design known as a microkernel was all the rage. Microkernels are much smaller than monolithic kernel. They move as many tasks as they can into non-kernel processes and then managing the communications between processes. Today's Linux world. By the mid-1990s, the most important features of Linux as it exists today had been established. Changes since then have included the following. Improvements in the kernel. The Linux kernel has seen massive changes since 1991, when it lacked many of the features we rely on today. Improvements include the addition of networking features, innumerable hardware drivers, support for power management features, and support for many non-x86 CPUs. Improvement in support tools. Just as work has progressed on the Linux kernel, improvements have also been made to the support programs on which it relies, the compilers, shells, GUIs, and so on. Creation of new distribution. As noted earlier, Slackware dates to 1993, and Red Hat, the predecessors to Red Hat Enterprise Linux, CentOS, and Fedora, originated in 1995. Other distributions have emerged in the intervening years, and some have been quite important. The Android OS, used on smartphones and tablets, for instance, has become very influential over the past decade. Linux's root remained very much in open source software of the 1980s and 1990s. Although a typical desktop or embedded OS user is likely to perceive the OS through the lens of the GUI, much of what happens under the surface happens because of the Linux kernel and open source tools, many of which have existed for decades. Using open source software. Broadly speaking, software can be described as coming in several different forms, each with different expectations about payment, redistribution, and users' rights. The number of categories varies depending on the depth of analysis and the prejudices of the person doing the categorization. One of them is commercial software. Individuals or companies develop commercial software with the intent to sell it for profit. Developers generally keep the source code for commercial source software secret, which means that users cannot normally make changes to the software except alter configuration settings that the software supports. In the past, commercial software was sold in stores or by email order, but today it's often sold via downloads from the internet. Redistributing commercial software is generally illegal. Microsoft Windows and Microsoft Office are both common examples of commercial software. Freeware. Freeware, like shareware, is available for free. Unlike shareware authors, though, the authors of freeware don't ask for payment. Sometimes freeware is a stripped-down version of a more complete shareware or commercial program. At other times, the author makes it available for free to promote another product. Examples include Windows drivers for many hardware devices or the Adobe Reader program for reading printable document format or PDF files. As with commercial and shareware programs, freeware generally comes without source code. Open source software. Open source software is defined by a set of 10 principles. The most important of these principles are: the user has the right to distribute the program, the source code must be made available, and the user has the right to make and distribute changed version of the program. The basic idea behind open source software is that software developed in a transparent manner is likely to be superior to software developed in a closed manner. This superiority and arguments against it come in several ways. One is better code. Exposing source code to the community at large means that it can be reviewed, judged, and improved on by any interested party. Obscure bugs might be found and squashed when otherwise they might linger and cause problems in a closed source product. However, The validity of this claim is not well supported by research, and smaller projects might not gain much in the way of interest from other programmers, so they might not benefit from outside code review. The other is more flexibility. By providing users with the source code, an open source project allows users to customize the software for their own needs. If users submit changes back to those individuals who maintain the software or release them as a new branch of the project, then everybody can benefit from such changes. Of course, critics would argue that this flexibility is only a benefit to those with necessary skill and time to make such changes, or those with the money to hire somebody to do it. The last one is lower cost. Although the open source definition does not forbid the scale of software, the distribution requirements means that open source software ends up being available free of charge. If you want support, though, you may need to purchase a support contract, which can reduce or eliminate the cost benefits. The last topic is understanding OS roles. Computers fill many roles in the world, and as the computers have become ever more common and less expensive, those roles have multiplied. Linux can serve as the OS for most of these roles, each of which draws on its own subset of support utilities. We briefly described the three of these roles: embedded computers, desktop and laptop computers, and server computers. Okay, first we'll looking at the embedded computers, such as mobile phones. Modern mobile phones use computers with OSs that range from simple to complex. Linux powers some of these mobile phones, usually in the form of the Android OS. The next one is IoT monitors. The Internet of Things, or IoT, consists of a small embedded system that monitor physical conditions such as temperature, humidity, light, or motion, and use the data to control motors, switches, cameras, and other devices. Exploring desktop and laptop computers. Laptop computers are similar to desktop computers from a system administration perspective. Both types of computers are often used by a small number of people for productivity tasks, such as word processing, web browsing, and managing digital photos. For brevity, we'll use the term desktop to refer to both types of computers from here on. Specific software that's required on most Linux-based desktop computers include the X Windows system, GUI or X for short, a popular desktop environment such as GNOME, KDE, XFCE, or Unity, a web browser such as Mozilla Firefox, an email client such as Mozilla Thunderbird or Evolution, a graphic editor such as the GIMP, an office suite such as OpenOffice or the similar LibreOffice. Linux distributions such as Fedora and Ubuntu typically install these popular desktop tools by default, or as a group by selecting a single install time option. These distributions are also designed for relatively easy maintenance so that users with only modest skill can install the OS and keep it running over time. Investigating server computers. Server computers can be almost identical to desktop computers in terms of their hardware, although servers sometimes require bigger hard drives or better network connections depending on how they are used. Many popular network server programs were written for Unix or Linux first, making these platforms the best choice for running them. Examples include web servers such as Apache, email servers such as SendMail and Postfix, databases such as MySQL, domain name system or DNS servers such as the Berkeley Internet Name Domain or BIND, and time servers such as the Network Time Protocol or NTP, and etc. In a large organization, each of these services may have a distinct associated server computer. It's possible, though, for one computer to run many of these server programs simultaneously. Most of these servers do not require a GUI, so server computers can do without X desktop environments or the typical desktop programs that you'll find on a desktop computer. One of the Linux's advantage over Windows is that you can run the computer without these elements, and you can even uninstall them completely. Doing so means that the GUI won't needlessly consuming system resources such as RAM. Furthermore, if an item such as X isn't running, any security bugs it might harbor become unimportant. Some distributions such as Debian, Arch, and Gentoo GUI configuration utilities. This makes these distributions unfriendly to new users. But the reliance on text mode configuration tools is not a problem to be experienced administrators of server computers. The people who maintain large server computers are generally technically quite proficient and can often contribute directly to the open source server projects that they use. These close associations between users and programmers can help keep server projects on the cutting edge of applications and utilities required in the real world. Note that distinction between desktop and server computers is not obsolete. A computer can run in a mixture of both types of software. For instance, you might configure desktop computers in an office environment to run file server software. This configuration enables users to share their work more easily with others in the office. In a home or a small office setting, running other servers on desktop computers can obviate the need to buy specialized hardware to fulfill those roles. Linux's development history is tied to that of Unix and to open source development in general. Open source software is provided with source code and the right to modify or distribute the source code. This guarantees your ability to use the software in ways that the original author didn't anticipate or support, provided you have the knowledge and time to alter it or the resource to hire somebody else to do so. These open source principles have led to a great deal of popular software, particularly in a server area. However, open source developers have been less able to capture the general public's existence with applications designed for desktop computers. Okay, I hope this is informative for you, and I'd like to thank you for viewing. Good luck.